All right, hello AP Calculus and welcome to your recap video number 2 for the AP exam. Our main topics that we're going to discuss are all of the theorems, going through each one. There was a good theorem review posted for your first semester final that you could also go back and look at. So I'll be going through this with a couple multiple choice, and then there will be a separate video going over the free response 2007 number 3, which is already in your packet. So hi and welcome. The intermediate value theorem was the first theorem that we worked on in calculus all the way back in August or September. If a function is continuous on the closed interval from a to b, and f of a is less than m, which is less than f of b, then by the IVT, there exists a C on the open interval, that was open, not closed, open interval, AB, such that f of C is equal to m. So that was all of our mathy wording of it for the intermediate value theorem. But what really is going on here, oops, didn't mean to move that. What's really going on here, if we draw a picture, so our function has to be continuous on a closed interval from a to b. So I'm going to have some function I can draw without picking up my pencil from a to b. This looks a little vertical, but I didn't mean for it to. And m is somewhere in between. This would have been f of a. This up here would be f of b. So m is somewhere in between here. I choose here. Then by the IVT, there exists a C somewhere between a and b, such that f of c is equal to m. So this was the one that we talked about. We walk continuous paths as humans. So if f of a is your home and f of b is being in your classroom, at some point you had to cross through the front doors of the school. Or if f of a is the ticket counter at the airport and f of b is you comfortably in your seat on your airplane, then at some point you had to cross through m, which would have been the security checkpoint. Okay? What often happens here is we got to remember we have to set up our y values. These are all dealing with y's, and it guarantees that there would be an input such that that is true. Oftentimes they'll give you something where f of a is positive and f of b is negative, and they want you to show that there has to be a 0. Well, we know that 0 is between all positives and all negatives, so by the IVT there has to exist a c such that f of c is equal to 0. I think that's it for the IVT. Next one is the mean value theorem, specifically for derivatives. So now as soon as we're going to start throwing in derivative language, it's not just enough that a function is continuous, it also has to be differentiable. So if f of x is continuous on the closed interval from a to b and differentiable, video glitch, my computer died on me, differentiable on the open interval AB, because remember we can't be taking derivatives at endpoints because it's like floating tangent lines. Where do they go? Then by the mean value theorem, there exists a value C such that f prime of C is equal to f of B minus f of A over B minus A. So this is the one where we have IROC, the instantaneous rate of change, is equal to AROC, the average rate of change. A picture of this, we use the example of the calculus teachers doing a drive, but we have a function that's continuous on a to b. We'll go mostly decreasing this time. And so what this says is that the slope of the secant line, which would be the red line along here, there is some place where the derivative, the instantaneous rate of change, is equal to that slope, which means that we would have parallel tangent lines. So remember, it just guarantees that there is a c. There could be more than one where that's true, but we're just saying that the c value does exist. So the slope of the secant line will equal the slope of the tangent line. What is the relationship between the mean value theorem and Rolle's theorem? So the mean value theorem is the more general case. Rolle's theorem adds on the caveat that f of a is equal to f of b. So that would be in your if part of your if-thens. Well, if this is true, then when you go to do f of a minus f of b, you're going to end up with, here's f of a, here's f of b that are equal. So the slope of the secant line is going to be 0, which means there's a horizontal tangent somewhere along the way. Keeping in mind, a horizontal tangent would imply maximum or minimum, because you have to go up and get back to f of b, or you go down and get back to f of b. So we will definitely have a critical number. So there will be a place where there will be a place c such that f prime of c is now equal to f of b minus f of a over b minus a, but really that's just 0. Okay, so Rolle's theorem is a very specific case of the mean value theorem where f prime of c is equal to 0 because f of a and f of b are equal. The mean value theorem for integrals then. If a function f of x is integrable, so you can take the integral on the interval from a to b, then there exists a value c such that the integral from a to b of f of x dx is equal to b minus a times f of c. So if we think about the last one, we said average rate of change was equal to instantaneous rate of change. Now what this is saying is boring old average rectangle is equal to cool new area under a curve, right? Because we can find that specific area under the curve. So what would happen here is this is the base and f of c is the height. So when you multiply them together, you end up with the area of a rectangle. The name to f of c, if you isolate it, is the average value. So it's the average height of the function over the interval from a to b. So remember, average value we find by saying 1 over b minus a, the integral from a to b of f of x dx is equal to f of c, because all we've done is we've isolated this f of c by dividing back. You can think about it as you're going to sum up everything and then divide back by the things that you summed, thus leaving you with some sort of an average. So what this looks like as a picture is I have some function that's nice, smooth, continuous. I can take the integral of it. And this perfect integral area is equal to, let's see, my heights go all the way up to here and all the way down to here. This looks like maybe an f of c. So this would be f of c. This would be c. I don't know if I really picked the best one, but that's okay. Where the area of this red rectangle, so it's going to have a width of b minus a and a height of f of c. If you were to multiply these two things together and find the area of this red rectangle, it would match the area of the green, because you kind of get like this is too much, this is a little bit over, right? And it kind of fills in the blanks. The average value then is when you just want to figure out what is the average blank. So the average temperature, the average velocity, the average acceleration, the average value. This then is your function. So if I want average temperature, average velocity, average acceleration, whatever it might be. All right, we got a couple of practice questions. I'm going to have you pause and try the question on your own, and then I'll give you a little summary. So pause your video now, go ahead and read through this, and then we'll compare answers. All right, so to start this one, I sketched just a little picture, right? All I know about this is that the function is continuous. So anything that deals with f prime is garbage from the beginning, because we don't know anything that this function is differentiable, so how do we even know that the derivative exists? We don't. F attains a maximum on the open interval from 2 to 4. Well, I could have just drawn straight from here to here, in which case my maximum is at 4, and I would need a bracket on that. That's supposed to be a bracket. So that one's out. F of 3 equals 15 would imply that we just have a straight line, but that doesn't necessarily hold true, right? This is also a function, okay, that's continuous, and that's not going to fit B. So it's going to be A. F of x is equal to 13, so that's like finding your m over to the side of 13. 13 is between 10 and 20, so the x value that we're looking for has to fall somewhere between the x values of 2 and 4. Okay, my computer's going very slowly. It's overworked. Too far. Given h of x equals 6x cubed, find the value of c such that h prime of c equals h of b minus h of a over b minus a. So this is using the mean value theorem. Go ahead and see if you can find all of these pieces first, and see if you can then find c. Pause your video and we'll compare. All right, so first thing, 6x to the third is differentiable and thus continuous because it's a nice, smooth, differentiable polynomial. H prime of c, I found to be h prime of x, so h prime of c goes here. And then I need to work to find the slope of that secant line. So I found h of 2 and h of 1, and I got 42. So my instantaneous rate of change, IROC, is equal to my average rate of change, AROC. And then I went through and I solved for C. C ended up being positive or negative, but I'm looking for an answer that falls between 1 and 2. So I want to keep the positive square root of 7/3. All right, last AP question. We have this graph. Says our function is continuous from -4 to 4. We've got some line segments. What is the average value? So whenever you see average value, you want to set up 1 over b minus a, the integral from a to b, of f of x dx. Okay, so I'm going to get you started with that. A and b right here. Think about how you're going to collect the area from a to b under f of x, knowing that we have 5 line segments. Think about geometry that you could use there. So go ahead and pause your video, and then we will compare. All right, so the first thing I would do is go through and find the area of each one of those triangles, and then the last one in red is a trapezoid, or a square and a triangle, your call. Keep in mind that the thing in blue would count as negative because we are integrating from -4 to +4, so we're going from left to right. Anything that drops below the x-axis is going to be counted negatives. So to get all of that integral, the integral from -4 to 4, I'm going to take these 4 numbers and add them up. So 1 over 4 minus -4 is 1/8. Adding up all of these numbers, the first 3 are going to cancel, and I'm left with just 1/8 times 3/2, which is 3/16. All right, this next one is the 2007 number 3, and there is a separate video going over this free response question that pertains to all of these theorems. So again, make sure for the theorem you're setting up all of your ifs. You've somehow indicated that you know the function is differentiable and therefore continuous, all of those different conditions that must be met. And I would look over the wording of your theorems because while you don't need to have them word for word on the AP exam, you will want to be able to justify your answers in a logical, mathematical way. All right, catch you next time.